Yeah, yesterday the entire math team met over here at Frank Wright, including the high school teachers. But there's times when I go over there and we meet over there. So this one time, after the meeting, I stepped outside and then I saw this parent that had just registered their son over there, and they wanted directions to Frank Wright. So, yeah. So check this out. So I get my my smartphone out and I show them Google Maps, and here they see that I show them that here's Imperial High School, and I tell them that they need to go over here to Frank Wright Middle School. And I said, so get in your car and drive through these houses like this, and that's how you get to Frank Wright. Now check this out. That is not true. Is that correct?
No.
That's one of the things that I use so that you guys understand that this line is not the slope. In the past, some of you saw a line, you thought slope. That is not true. Slope is the ratio of rise to the run, or the difference in y to the difference in x. And how can we do that? By showing it like this. This is probably as simple as I can show it. Is by saying, okay, lady, here it goes. To get to Frank Wright, you're going to go from here. I see that here's one street. Go through the parking lot over here in the back, but here's one block, 2, 3, 4, 5, 6, 7 blocks. And then from here, you're going to turn and go 1, 2, 3, 4. 4 blocks. That is the slope. And it's presented always in a fraction form, because if we go from this point to this point, it forms a line, and the line forms a fraction. Do you guys see the fraction? Boom. That just happened. That just happened. Pretty cool, right? So therefore, that will get your brain, that's why I do this story, because it helps to get away from saying, oh, well, I don't go through the houses. No, because we never drive through the houses, right? That's why this line is not the slope. What is the slope? The ratio of the rise to the run. That's the slope. Everybody with me? So with that said, our objective for today, I can define and find the slope of the line. Let's read together. 1, 2, 3. I can define and find the slope of the line. And by the way, I just made you guys rappers. I can define and find the slope. Never mind. All right, copy that, please. Right light. Thank you. So you have the objective. Let me give you the definition for slope. So slope, what is slope? Here's the definition. It says, slope is the change in y value, which is a rise, per unit of change in x value, which is a run. It's always the same, also known as rise over run, or the slope of the line. Notice that it says here, it's not the line, right? What is slope? It's the slope of the line. It's not saying that slope is the line. Does that make sense? Yes, Mr. Q. All right, good. Copy that. 20 seconds. What? So it says rise over run. So that implies writing a what? Fraction. A fraction. So here's my fraction. And I wrote it like this so you can remember the difference between rise over run. So let me add some special effects. Watch. Let me move this over. Here we go. It's running. You see that it's running?
Yeah.
No? You're saying okay. Anyways, check this out. It says slope is the change in y, which is the rise. So that means the rise represents what variable? Change in what? Y. So check this out. This is the easiest way that I can put it so that you can remember which variable goes with which, or the change in what. And the unit change in x value, which is the run. So this is the x value. Are we there? Now check this out. If I was to zoom in so you guys can see what I'm talking about and how it's going to help you the way I write it like this, if I put a little head here for the X, it looks like the X is running. Do you guys see that? Do you guys see that? Yeah, and if I put a little head here for the Y, it looks like the Y is rising like this. That's pretty cool, huh? I know. I was like, sometimes I wake up and I'm like, wow, you just came up with that? Yes.
It's a Y? No, it's like a pointing up. Yeah.
All right, anyway, so here we go. So as examples, I want you to write this down, please. If you have your colored pens, that would help. Write these examples down. This one in green, this one in red, this one in blue, this one in black. Copy that, please. So, check this out. Pens down, please, eyes up here. So, I'm going to go over the definition to make sure we understand this. According to the definition, it says it's the change in Y value rise per the unit of change in X value. It's always the same. Always the same means that it doesn't break the pattern, or it stays constant. So, check this out. The easiest way that I can think of explaining this, that we can go without saying that this is the slope just by looking at the line, is by thinking about the direction and inclination of the line. Okay? Two things, direction and inclination. However, before I do that, when you guys leave here, you guys are going to go to your endeavors at the high school, continue with your education over there. From there, you guys graduating, going into college. Some of you are going to go out of town, some of you go out of state. Well, there's such a thing out of here when you leave that they call this one thing, and it does exist, by the way. They call them escalators. And check this out. Escalators, you like step on one step, and it takes you either up or down. No, believe it or not, it does exist. Anyway, so watch. So watch. So, with that said, I'm going to use that example to illustrate the slope. Now, how do we read lines? The same way we read here. We go from left to right. The farthest point on the left is the beginning. The farthest point to the right is the end. So we're going from left to right. From left to right. From left to right. Okay, so watch. I'm going to focus right now on this the green line. So I'm going to draw you right here. All right, so that's you. And imagine that the green line is an escalator. So watch. So this is the first point, and guess what? Look. Which way is it going? Up. That's why it's a positive. Everybody with me? Now let's look at the red line. Would I get on the escalator here or over here? If we're going from left to right, it would be up here. Is that correct? Yeah. So watch. I know, and it's going down. That's why it's a negative. But here we come into a paradigm right here. A dilemma. Watch. We can either get on here or here. We're not sure. Is that correct? From left to right. That's why it's undefined. So these are not escalators. They're not elevators. Escalators are only what? Diagonal. Is that correct? Either they go up or they go down. They escalate, right? This is called something else. I'm going to look for it on Google when I have a chance. But I think they're called terminators. No? Never mind. No, I don't know what they're called. But they have them at the airports when they walk a little bit fast, right? No? Yeah. Yeah. Terminator is a movie? Be nice. All right. All right. So, does everybody understand the difference from one slope to another slope? So we have 4 different slopes. Positive, it goes up. Negative, it goes down. Undefined, and 0. So now let me show you what does not have slope. Watch. Look at these. So think about it. Talk it over with your neighbors. Why don't these have slope? Right. So one thing that we are seeing is that it breaks from being a straight line or a constant rate. Is that correct? That's why the definition says it's always the same. It's a constant rate. Do we have a constant rate here? No. It breaks the rate here and then continues. This one, it goes down and then it goes up, so it breaks the constant rate. So what is slope? What is the most important thing to remember about slope? Is that it's a ratio, it's a fraction form, rise over run. And number 2, it's only found in linear equations or lines. Copy that, please. Okay, also guys, from now on, the symbol that we're going to use for slope, I'm going to write it right here next to it in the parentheses, is M. M. Now, an easy way that I can think of to remember that, yes? Either way. So M. An easy way to remember that the symbol for slope is M is like this. Some of you are saying, why not use S? S is used for something else. So M. Now that winter is here, there's families that go out to the mountains and go to the snow, right? Yeah. Who's heard of people going into the slopes? And where are slopes found? In the mountain. Bam! Is that an easy way to remember? Yes, right? So that's why slope is using the letter M. Okay? Here we go. Let's continue. So let's write these steps down, please. Oh, wait. We don't need steps because we have an escalator. Just kidding. Write these down, please. Here we go. 3 simple steps. Write these down, please. Step 1, identify 2 points on the line or a table and write the coordinates. Step 2, compute the vertical change over the horizontal change. Step 3, simplify. Copy that, please. All right, so 3 simple steps. Number 1, identify 2 points on the line or table and write the coordinates. So what is imperative? That you identify them and you write the coordinates, yes? Step 2, you're going to compute the slope, which is vertical change over horizontal change. Step 3, simplify. Fairly simple? All right, so get your graph paper. You're going to use a big coordinate plane. And we're going to copy this one onto that. This one. And let me give you 2 points of reference. This one and this one. So, for those of you that don't see it, let me get my coordinate plane, the bigger one. Here we go. I'm going to place a point here. Oh, wow. Here we go. Oh, wow. Okay, let's see. What does it keep doing? I don't know. All right. The first one is 4, 3. There it is. The other one is -4, -1. You're going to get your ruler and draw a line going through the 2 points, but make sure you extend it as far across the coordinate, the coordinate plane as possible. Okay? Make sure it's nice and straight like mine.
I was expecting it to be all curvy.
I mean, I know it's not going to be as perfect as mine, but try. All right, so here we go. Let me zoom in so that you can see a little bit closer the points. There they are. So, let's see. Marissa, read us the steps, please. Step 1.
Identify 2 points on a line or a table and write the coordinates.
Okay, so we identify the 2 points, so what do we need to do? Write the coordinates. So right underneath that, I'm going to write the coordinate for this one, which is 4, 3. And the coordinate for this one is? Negative 4, negative 1, okay? Step 2, compute the rate of change. So that means we're going to give the directions to the lady again, right? So check this out. We're going from this point to this point. Are we there so far? So here we go. So from here to get to that point, am I going to go straight on the line? No. I need to do a rise. What is the rise? 1, 2, 3, 4. Label that, please. 4. And from this point, how many to the right? 1, 2, 3, 4, 5, 6, 7, 8. So let's write our slope. What letter did we use for the slope? What symbol? M equals rise over run. Okay, so M equals, what was the rise? 4, and what was the run? 8, and if we simplify that, which is step 3, 1 over 2. That's it. No, we're still not there. That's the next one. I mean, I understand. Here we go. Yes. Here goes the answer. M equals 1/2. All right. Now check this out. Now, according to the definition, it says that it's a constant rate of change. And what is the other key phrase? Always the same. Is that correct? So what they're saying is that if we pick 2 other points that are still on that line, doesn't matter what points they are, I should get the same slope. Is that correct? So watch. I'm going to use, let's see, negative 2. Okay, negative 2, 0. So everybody get this one, plot this point. And I'm going to pick the next one. I'm going to pick one way over here. 10, 6. So label your coordinates, 10, 6, negative 2, 0. Okay. So let's get from this point to that point. Okay, lady, you go up 1, 2, 3, 4, 5, 6 blocks. So I label that 6. And from here we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to the right. So if I write that as rise over run, what is it? 6 over 12. And what is 6 over 12? 1/2. Is it the same?
Yeah.
How can we count the point at the top and not at the bottom? Because here's where we start. When I ask you to take steps, where you're at is the point, and your ending spot, you have to count. Yeah.
Can you start from 10, 6?
Going that way?
Yeah, like down.
Going down and like that? Yeah, but for right now, let's go, because I want you guys to, your brain to get used to rise, over, run. Everybody with me? How are we doing? Good? Okay, let's do another one. So, does everybody see how it doesn't matter which points we choose, we're always going to get the same rate? Is that correct? Okay, let's continue. So, copy this next one. Let me minimize this. Okay, let me zoom in. Turn your paper over on the little graph in the back. Copy this one. Copy that. Identify your points, write your coordinates, and find me the slope. Go. Alright, so you should have written 0, 3. Is that correct? And negative 2, 0. So then, therefore, it's 1, 2, 3, and 1, 2. So my slope is 3 over 2, and we're going to leave it like that. It's simplified to lowest terms as long as it's not in mixed number or decimal. Are we there? All right, let's go to the next one. Copy this one down on a different graph. Let me zoom in so you guys can see it. Example 1C. And here they give you 2 points already with the coordinates, 0, -3, and 4, -5. Draw your line, find me the slope. They already did everything for you right there. Go. Okay, let's see. So we're going from here to here. How many steps? 1, 2. Did we identify it's 2? But since it's going down, it's a -2. Well, notice that I did steps down. From here to here, I take 2 steps down. Is that correct? That's why it's a -2. And from here to here, we're still going to the right. 1, 2, 3, 4. It's 4. So my slope is -2 over 4, which is -1/2. M equals -1/2. Yes?
I thought you were starting at like the lowest point there.
No, we're always reading from left to right. Which is the first point from left to right? This one. From left to right. So now, look up, please. Watch. Look at the previous one. Let me zoom out. We started with this one. Which direction do you see this line going? Up, and it's a positive. Look at this one. Up, and it's a... Look at this one. It's a negative. So if I was to give you this next one, look up, please. Oh, sorry. If I was to give you this next one, what would it be? Negative. So if with that same reasoning, what is this one?
Undefined.
And this one? Undefined and 0. Everybody understand? Now we get it? So once again, if I was to give you another example, what is this one? And this one? All right, so this is where I wanted to get to. So I need your full attention. Here it goes. This is where we're going to develop the main concept. Here it goes. So I'm going to use this without any grid or any numbers. This is what we call conceptual development. Here it goes. And I'm going to place 2 points here, this one and this one. This is point 1 because we're reading it from left to right. This is point 2. Of course, this one has an x value, so does this one, right? This one has a y value, so does this one, right? So, if I was to ask you for coordinates for the first point, what would we write? X and y. How about for the second point? X and y. Oh, sorry. X and y. Are we there so far? But isn't this the same as this? Wouldn't we get confused by saying x and y, x and y? So how would we distinguish point 1 from point 2? Let me show you. X sub 1, y sub 1, x sub 2, y sub 2. Does that make sense now? Yes, because this is x sub 1, x sub 2, y sub 1, y sub 2. Are we there so far? Yes. So, now let me give you some values. Pay attention, please. Let's say I gave you the value for this one that it's 2, and the value for this one that is 6. Are we there? And what if I said that the values for y, for this one it was, let me use a different color. For this one it was, give me a number. Okay, 1, and this one was 8. Okay, so watch. Are we there so far? So let's give, we want to find the slope that goes through those 2 lines, and we're going to give a lady the directions. Here we go. So to get from here to here, I need to take steps up. So right here, this one is at 1 and needs to go to 8. So how many steps up to get from here to here? 7. Are we there so far? So from here to here, we're at 2. We need to get a 6. How many steps? 4. Are we there so far? So my slope, which is rise over run, pay attention, here we go, is 7, okay, I'll wait, 7 over 4. Are we there so far? Okay, so now here goes the key ingredient. Look up please, or you're going to miss it. Look up to the screen or you're going to miss it. So, pay attention. So hold on. So what did we do here? Subtracted what? The 8 from the 1. So that means I did, pay attention, hold on, I'm still not done. I did y2 minus what? y2 minus y1. And what did we do here? x2 minus x1. Does that sound familiar? And that is our formula for slope. M equals y2 minus y1 over x2 minus x1. And all you need is the coordinates that they gave you to find the slope. So therefore, Lauren, leave it on the seat, please. For home plate for tonight, you need to go to pages 176 to 178. All have a good one, guys. See you guys tomorrow.